Nous can realize real-time face detection and tracking through its cameras. In this lesson, students first build another form of Nous Gimbal, according to the building manual, and try to control the two servos of Nous Gimbal to realize the up, down, left and right movement of Nous Camera in this form. Then, learn how to use coding blocks related to face detection and program to transform the Nous Gimbal into an intelligent ID camera, which can remind people how to find the best photo area based on the face position information and complete automatic photo taking. Face detection is the first step of the entire face recognition algorithm. It is a classic problem that has been deeply studied in the field of machine vision. Machines can detect the presence of human faces and determine their positions from various scenes through the face detection function. It has important application value in security monitoring, witness comparison, human-computer interaction, social networking, and other fields. Digital cameras and smartphone devices have widely used face detection technology to achieve functions such as focusing on faces during imaging and organizing and classifying atlases. In addition, various virtual beauty cameras also require face detection technology to locate the face and then use face alignment technology to determine the range of the skin and facial features of the face and then perform beautification. In this lesson, the form Nous Gimbal will be used to complete the color tracking task. Nous Gimbal has no wheels. Its upper and lower servos are mainly used to drive the Nous Camera up, down, left and right. Servo 1 can control the Nous Camera to rotate left and right horizontally, and Servo 2 can control the camera rotates vertically up and down. In the Nous Gimbal mode, the initial angle of Servo 1 is 0 degrees and the initial angle of Servo 2 is 90 degrees. Facing the Nous Gimbal camera, when the angle of Servo 1 increases, the camera rotates to the right, and vice versa. When the angle of Servo 2 increases, the camera rotates upward, and vice versa. We can write a test program and use the buttons up, down, left, and right on the Nous hub to control the servo to rotate in the corresponding directions. In this section, students independently build Nous Gimbal and then write the test program to control the movement of Nous Camera. There are 3 coding blocks related to face detection, as shown below. After turning on human face detection, the Nous Camera can capture the facial information in real time and show it on the Nous screen. There are 5 points distributed in the rectangular frame to locate the key facial information. The Nous Camera may not be able to detect facial information when the following situations occur. It is mainly used in conditional statements. The Human Face Center coordinate coding block can be used to lock the position of the face relative to the Nous Camera. It contains a total of 4 parameters. X, Y refers to the coordinate information of the center point of the face. Width, height refers to the width and height of the detection frame for face detection. When the face is in the middle of the screen, X equals 120, Y equals 120, as the face is displayed on the screen as a mirror effect. When the face moves to the right of the camera, the face on the screen moves to the left, thus X gradually decreases with a minimum value of 0. When the face moves to the left of the camera, the face on the screen moves to the right, thus X gradually increases with a maximum value of 240. When the face moves upward, Y gradually decreases with a minimum value of 0. When the face moves downward, Y gradually increases with a maximum value of 240. When the face is closer to the camera, the displayed face will be larger, and the corresponding width and height values of the face detection and recognition frame will also be larger. Otherwise, the values will be smaller. As width and height increase or decrease simultaneously, usually we only need to use one of the parameters. Using the Nous' face detection coding blocks, we can design an intelligent ID camera. Here, first take the parameter X as an example to complete the intelligent ID photo project. First, write a thread to adjust the approximate position of the Nous camera by pressing the up, down, left, and right buttons so that it faces the person's face. Then, write another thread, turn on face detection. When the Nous camera detects X greater than 140, the face is to the left. At this time, the voice will prompt, "Please move to the right." Nous camera detects 0 less than X less than 100. The face is to the right. At this time, the voice will prompt, "Please move to the left." We need to set up a variable no face. Only when no face information is detected for 1 second in a row, it will be judged that the face is out of the camera and a voice reminder will be issued. When x equals 0, the variable no face is increased by 1 every 0.1 seconds. If the variable no face greater than 10, it is determined that no face has been detected and a voice reminder is issued. Otherwise, the variable no face is reset to 0 and the judgment is made again. In the same way, a variable face needs to be set up. When 100 less than x less than 140, the variable face equals 0 and is increased by 1 every 0.1 seconds. If the variable face is greater than 10, it is determined that the face is really in the center. Otherwise, the face will be reset to 0 and rejudged. Nous does not have the function of taking photos directly. We can first use the voice prompt cheese and then turn off the face detection and screen preview. At this time, the screen will be fixed with the image the moment when the face detection and screen preview are turned off, and the effect is the same as taking a photo. After taking a photo, if more photos need to be taken, please add the conditional statement as shown below. The whole program is shown below. In this section, students try to finish the whole project by themselves. Students share the problems they encountered during the project and their solutions.